Hello, my dear students. Today we are going to continue our discussion in chapter 5, which is organic chemistry. We are going to discuss phenols. We are going to discuss their preparation and their chemical properties and physical properties and their uses. And we are going to discuss some questions on them. So let us start. Phenols. They are hydroxy aromatic compounds where one or more hydroxyl groups are directly attached to the carbon atoms of benzene ring by removal of one or more hydrogen atoms. As shown on the screen, here the benzene ring hydrogen atom is removed and replaced by hydroxyl group. We call this molecule is phenol or carbolic acid and IUPAC name hydroxybenzene. Another example for phenols is the benzene ring attached to hydroxyl group instead of two hydrogen atoms. This molecule is called catechol and its IUPAC name 1,2-dihydroxybenzene. This next example, my dear student, the benzene ring attached to 3 hydroxyl groups instead of 3 hydrogen atoms, and this compound is called pyrogallol and its IUPAC name 1,2,3-trihydroxybenzene. Now we are going to discuss phenol or carbolic acid or hydroxybenzene in details that has molecular formula C6H5OH. The uses of phenol. It is used as a starting material for many industrial products. For example, polymers, dyes, disinfectants, salicylic acid derivatives as aspirin and picric acid. Now we are going to discuss the preparation of phenol. From fractional distillation of coal tar, from halogenated aromatic compounds, and this process is called alkaline hydrolysis. By hydrolysis of chlorobenzene with sodium hydroxide at high temperature 300 degrees Celsius and high pressure 300 atmospheric pressure. As shown on the screen, chlorobenzene plus sodium hydroxide at 300 degrees Celsius and 300 atmospheric pressure, it gives phenol and sodium chloride is produced. Now we are going to discuss the physical properties of phenol. It is solid corrosive substance to the skin. It has characteristic smell. Its melting point is 43 degrees Celsius. It is sparingly soluble in water and it is completely miscible with water at 65 degrees Celsius. Now, my dear students, we are going to discuss the chemical properties of phenol. First, we are going to discuss the reaction that is specific to the hydrogen of the hydroxyl group. My dear student, it is known that the acidic property is attributed to the presence of positive hydrogen ion or proton. So, when the active metal, for example sodium or potassium, reacts with phenol, the metal replaces the hydrogen of the hydroxyl group, giving hydrogen gas, and metal phenoxide or metal phenate as sodium or potassium phenoxide or phenate is produced. As the equation proceeds on the screen, phenol plus sodium gives sodium phenoxide C6H5ONa, or we can say sodium phenate, and releasing hydrogen gas. We have good reason in this point. Alcohols and phenol react with strong metal, for example sodium or potassium, and the hydrogen gas is evolved. The reason for that, due to the presence of the hydroxyl group OH bond, which is polar covalent bond, so the electrons pair of the bond are shifted towards the oxygen atom of the hydroxyl group, and this facilitates the breakdown of the polar bond, so the metal atom can replace the hydrogen of the hydroxyl group. As the equation proceeds on the screen, C2H5OH plus Na, it gives C2H5O Na plus hydrogen. Here ethanol plus sodium gives sodium ether oxide and the hydrogen gas is produced. The same takes place with phenol, C6H5OH plus Na, phenol plus sodium. It gives C6H5O Na, sodium phenoxide or sodium phenate, and the hydrogen gas is produced as shown on the screen. We have give reason also in this point. Phenol reacts with alkalis as sodium hydroxide or caustic soda and named as carbolic acid, while alcohols don't. The reason for that, because the polarity increases in case of phenol due to the presence of benzene ring in phenol, which increases the length of OH bond and its weakness, which facilitate the separation of the positive hydrogen ion. As the equation proceeds on the screen, phenol plus sodium hydroxide, it gives sodium phenoxide C6H5O Na plus water or sodium phenate and water. Here, my dear student, we are going to compare the effect of adding metal and metal hydroxide on alcohol and phenol. Here is a reaction with alcohol or phenol C6H5OH. Here sodium reacts with alcohol, gives sodium alk oxide, and hydrogen gas is produced, while phenol gives sodium phenoxide and hydrogen gas produced. While on the reaction with sodium hydroxide or caustic soda, the alcohol has no reaction, while phenol gives sodium phenoxide C6H5O Na or sodium phenate, and water is produced. We have give reason in this point. Phenol is considered as an acid named in industry as carbolic acid. The reason for that, due to the polarity of the OH bond and the presence of benzene ring, which increases the length of the OH bond, the hydroxyl group, and its weakness, which facilitates the separation of hydrogen ion. Now we are going to discuss the reactions that is specific to the hydroxyl group. And we have give reason in this point. Phenols don't react with hydrogen halides or halogen acids. My dear student, when they are in gas state, called hydrogen halide. When they are in aqueous solution, called halogen acid. While alcohols react easily under normal condition. The reason for that is due to the strong binding of oxygen of hydroxyl group of phenol to benzene ring. This makes the bond shorter and stronger, and so it is impossible to eliminate the hydroxyl group from phenol when it reacts with acids, while alcohols react easily with acids. Now, my dear student, we are going to compare the effect between adding hydrogen halide or halogen acid to alcohol and phenol. Here is the reaction with alcohol or phenol, the reaction with hydrogen chloride or hydrochloric acid. Here alcohol gives alkyl halide and water is produced, while phenol don't react due to the strong bond of oxygen to benzene ring. Now, my dear students, we are going to discuss the reactions that are specific to the benzene ring. We are going to discuss the nitration of phenol. Phenols react with concentrated nitric acid in presence of concentrated sulfuric acid, and this forms 2,4,6-trinitrophenol, which is known commercially as picric acid. As the equation proceeds on the screen, phenol plus 3 molecules of concentrated nitric acid in the presence of concentrated sulfuric acid, it gives 2,4,6-trinitrophenol, which is picric acid as shown on the screen, and releasing 3 molecules of water. My dear students, picric acid is used in the manufacture of explosives and the treatment of burns, and it gives the skin yellow color, which is difficult to be removed, and it remains for several days until the skin is corroded. Here we are going to discuss polymerization by condensation reaction. The reaction of phenol with formaldehyde is an example of condensation polymerization reaction. Phenol reacts with formaldehyde HCHO in acidic or alkaline medium to form copolymer, and then polymerization process continue and then form bakelite polymer. Here, my dear student, bakelite has dark brown color. Bakelite is a type of thermosetting cross-linking plastic which is heat resistant. Bakelite is used in the manufacture of some electric instruments and ashtrays. Now we are going to discuss the detection of phenol. On adding few drops of iron 3 chloride solution to phenol, a violet color is produced as the following animation shows. Here, my dear student, we are going to put some phenol in a beaker, and we are going to add solution of iron 3 chloride. We observe the violet color appears due to the presence of phenol, which is used for detection of phenol as shown on the screen. Another method for detection of phenol is done by adding bromine water, which means bromine dissolved in carbon tetrachloride to phenol. A white precipitate is produced due to the presence of phenol. My dear student, we have a question here, how to differentiate between ethanol and phenol. Here the experiment, adding iron 3 chloride solution to both of them. Here the observation, if violet color appears, so it is phenol. If no violet color appears, so it is ethanol. Now, my dear students, we are going to discuss some questions on phenols. First type of question, choose the correct answer. 1,2,3-trihydroxybenzene is known as what? Phenol, pyrogallol, catechol, or carbolic acid. If you think about it, yes, it will be pyrogallol. Next point, reaction of phenol with formaldehyde in acidic medium is example for polymerization type is condensation, addition, alcoholic. All are correct. If you think about it, here the reaction will be condensation polymerization. Next type of question, my dear students, write the scientific term. A type of thermosetting cross-linking plastic which is heat resistant. Yes, the answer is bakelite. Next point. Addition of water to alkene in the presence of concentrated sulfuric acid. If you think about it, yes, it will be catalytic hydration. Next point, polar hydroxyaldehydes or polyhydroxy ketone. If you think about it, yes, it will be carbohydrates. The product of oxidation of secondary alcohol, if you think about it, yes, the answer it will be ketone. My dear student, remember, oxidation of primary alcohol takes place in two steps, giving acid, while oxidation of secondary alcohol takes place via one step only, gives ketone. The reaction of acid with alcohol in the presence of concentrated sulfuric acid is called what? If you think about it, yes, it will be ester formation or esterification. Next type of question, how to differentiate between 1-propanol and phenol. Here's the experiment. Add bromine water to both of them. His observation, if white precipitate is formed, it is phenol. If no white precipitate is formed, it is 1-propanol. Ethanol and tertiary butanol. By adding acidified potassium permanganate solution to each of them, then heating in water bath. Here ethanol and tertiary butanol. Here ethanol, the solution is decolorized, while the solution is not decolorized in case of tertiary butanol. Next point, 2-propanol and 2-methyl-2-propanol. Here's the experiment. Add acidified potassium permanganate to both of them. If the violet color is removed, it will be 2-propanol. If the violet color remained, so it will be 2-methyl-2-propanol. Next type of questions. Illustrate by the balanced chemical equation how you can obtain picric acid from chlorobenzene. As shown on the screen, chlorobenzene plus sodium hydroxide in the presence of 300 degrees Celsius and 300 atmospheric pressure, it gives phenol and sodium chloride is produced. Then phenol by nitration with conc nitric acid in the presence of concentrated sulfuric acid, it gives picric acid or 2,4,6-trinitrophenol and 3 molecules of water is produced. Sodium ethoxide from ethylene. As the equation proceeds on the screen, ethylene on catalytic hydration in the presence of concentrated sulfuric acid from 80 till 110 degrees Celsius, it gives ethanol. Then ethanol reacts with sodium, giving sodium ethoxide and releasing hydrogen gas. Next point, phenol from benzene. As the reaction proceeds on the screen, benzene plus chlorine gives, in the presence of iron 3 chloride, chlorobenzene, and then hydrogen chloride is produced. Then chlorobenzene plus sodium hydroxide, alkaline hydrolysis, 300 degrees Celsius and 300 atmospheric pressure, it gives phenol and sodium chloride is produced. Picric acid from ethine. Here, ethine or acetylene on red hot nickel tube, it gives benzene. Then benzene in the reaction with chlorine in the presence of iron 3 chloride, it gives here chlorobenzene and removing hydrogen chloride. Then chlorobenzene, when reaction of sodium hydroxide at 300 degrees Celsius and 300 atmospheric pressure, it gives phenol and releasing 1 mole of NaCl. Then phenol on nitration plus conc nitric acid in the presence of conc sulfuric acid, it gives 2,4,6-trinitrophenol and releasing 3 molecules of water. Next type of question. Correct the underlined words. On reaction between acidified potassium permanganate with methanol, acetic acid is formed. Yes, if you correct this, it will be formic acid. Next point. The chemical reactions of glycerol show it is tertiary alcohol. So it is wrong, and if you correct it, it will be trihydric alcohol. Next point. Hydrolysis of ethyl hydrogen sulfate produces ethylene glycol. If you think about it, yes, it will be ethanol. Sodium hydroxide reacts with chlorobenz to form toluene. Yes, it is wrong, so the correct here it will be phenol. Next type of question. Arrange the following in an ascending order according to their boiling point. Ethylene glycol, ethanol, sorbitol, glycerol. Yes, the answer is ethanol less than ethylene glycol less than glycerol less than sorbitol. Next type of question, give reason for. Phenol reacts with alkalis as sodium hydroxide and named carbolic acid while alcohols don't. Because the polarity increases in case of phenol due to the presence of benzene ring in phenol, which increases the length of the OH or hydroxyl group, and its weakness, which facilitates the separation of hydrogen ion. As the equation proceeds on the screen, C6H5OH plus NaOH gives C6H5O Na plus hydrogen. Phenol plus sodium hydroxide gives sodium phenoxide and water is produced. Next point. Phenol is considered as an acid named in industry carbolic acid. Here, due to the polarity of the polar hydroxyl group and the presence of benzene ring, which increases the length of OH bond, which its weakness, which facilitates the separation of hydrogen ion. Next point, phenol don't react with hydrogen halides or halogen acids, while alcohols react easily under normal condition. The reason for that, due to the strong binding of oxygen of hydroxyl group of phenol of benzene ring, and this makes the bond shorter and stronger, so it is impossible to eliminate the hydroxyl group from phenol when it reacts with acids, while alcohols react easily with acids. Write the scientific term. Addition of water to alkene in presence of conc-sulfuric acid. Yes, the answer is catalytic hydration. Alcohols that give aldehyde then acid when they are oxidized, if you think about it, yes, it is primary alcohol. Polyhydroxyaldehyde or polyhydroxyketone is what? If you think about it, it is carbohydrate. Next point, the product of oxidation of secondary alcohol is what? If you think about it, yes, it will be ketone. Reaction of acids with alcohol in presence of concentrated sulfuric acid, if you think about it, yes, it will be ester formation. Alcohols that are difficult to be oxidized by normal oxidizing agent as acidified potassium permanganate, if you think about it, yes, it will be tertiary alcohol. All these alcohols are oxidized by acidified potassium permanganate except what? 2-methyl-2-propanol, ethanol, isopropanol. Yes, the answer is 2-methyl-2-propanol. The reason for that is tertiary alcohol. Next point, when 2-propanol reacts with conc-sulfuric acid at 180 degrees, what is obtained? Propyne, ethine, butane, propene. If you think about it, yes, it will be propene. Next point, oxidation of alcohol of chemical formula CH3CH3CH2OH gives what? Aldehyde only, ketone, aldehyde then carboxylic acid, ether. If you think about it, yes, it will be aldehyde then carboxylic acid as it is primary alcohol contain group CH2OH. Next point, oxidation of alcohol chemical formula CH3CHOH CH3 gives what? Aldehyde only, aldehyde, then carboxylic acid, ketone, ether. If you think about it, yes, it will be ketone. Next point. Reaction of acids with alcohols in the presence of dehydrating agent is called what? Hydration, esterification, neutralization, oxidation. If you think about it, yes, it will be esterification. The reaction of 2-propanol with concentrated sulfuric acid is called what? Hydration, dehydration, neutralization, oxidation. If you think about it, yes, it will be dehydration. Next point. The compound obtained from the following reaction, C2H5OH plus CH3OH in the presence of sulfuric acid at 140 degrees Celsius gives C2H5OCH3 and water is considered from what? Aldehydes, carboxylic acid, ethers, esters. Yes, the answer is ether. My dear students, we have finished our program today. I hope you understood all the points that we discussed today. So till we meet again, my best wishes